If you go to the Neotropics, you find this wonder of diversity. There's so many different animals, and one of the special things that evolved is actually the ability to hover.
Both hummingbirds and nectar bats evolved to hover in front of flowers to reach the energy-rich resource, nectar. We traveled down to Costa Rica to compare how hummingbirds and nectar bats hover.
A real downside from working in the lab is that you have no access to diversity. It's just not possible to study so many species. Ideally, you want to actually bring your lab to the diversity. In this catch and release field study, the hummingbirds would come to the lab during daytime, and they would just be there for a couple of hours.
We collaborated with the Stanford ecology department. So they would catch birds and bats during the day and night, and then we'd transport them to our field station, where we'd train them to feed from a little artificial flower, and then we'd film them with high-speed cameras as well as measure their forces.
It's sort of a scale to weigh the bird, but then mid-air. The smallest was actually about 2 grams, so really, really tiny.
And as they're flying, they generate pressure waves that are transmitted at the speed of sound to the bottom and top of this kind of closed flight volume. By using aerodynamic force plates, which are basically really sensitive scales on bottom and top of this closed volume, we can measure the instantaneous vertical force that these hummingbirds and bats are generating. We were able to compare over 100 different individuals of hummingbirds and bats. We had 17 species of hummingbirds and 3 species of bats. One of our biggest findings was that all of the hummingbird species seem to generate very similar vertical force on the downstroke and the upstroke, with a very significant amount on the upstroke.
Across 17 species, they all did the same. It was really surprising actually to us. And what's really special in hummingbirds is that they're very good at this. They can actually generate lift at both the downstroke and the upstroke.
But the bat species really generate less lift on the upstroke. But interestingly, the nectar bats generate more upstroke force than the fruit bats, as they kind of invert their wings a little more.
So hummingbirds are actually aerodynamically much more efficient. But bats make up. What they do is they have a gigantic wing, and they can move that wing much slower. And that makes them much more energetically efficient. And so if you compare hummingbirds to bats, they're actually equal.
Just interested in how these different species evolve and why they want to generate lift in the upstroke. But secondarily, from a robotic perspective, if we learn things from how these hummingbirds and bats can hover efficiently, then we can apply that as we design our new micro-air vehicles and robots.
For more, please visit us at stanford.edu.